question asked in CSE department in the year 2024. Consider the circuit shown below where the gates may have propagation delays. Assume that all signal transitions occur instantaneously. That means the signal transition taking place at X, either changing from 0 to 1 or 1 to 0, taking place instantaneously without any delay. Similarly, wires have no delay. That means when I change the signal at this end, within no time it reaches the input of the AND gate. Similarly, this wire is also not having any delay. Which of the following statements are correct for about the circuit? Now there are 4 options given. Before we verify each of these options, let us go through the fundamentals about propagation delays. Propagation delay means whenever we apply some input to a logic gate, it takes some finite amount of time to reflect the change in input at the output. This time interval is called propagation delay. For instance, if the input changes from 0 to 1, your output may be changing from 1 to 0. The difference in time interval, right? Let us say at 50% it reaches at time t1. Your output reaches the same 50% at time instance t2. The difference between t1 and t2 is called propagation delay. The next one we need to understand is that logic 0 and logic 1 transients. Logic 0 transient means, as you can observe in the diagram, the signal normally at 1, for a moment it changes to 0, then once again it is coming back to logic 1. So it's a temporary fluctuation or a momentary glitch that takes place in your output signal. Similarly, logic 1 transient means changing from 0 to 1 for some time, again coming back to 0. With these fundamentals, now let us check all the 4 options. The first option says that with no propagation delays, your output Y is always at logic 0. So let us verify that. Initially we have 0. When I apply 0 to an AND gate, what happens to the output? It remains 0. Even though the 0 goes here, at the NOT gate output it becomes 1. Because one of the inputs at 0, your output will be 0 only. Now you change from 0 to 1. So this changes to 1. However, when this changes to 1, the NOT gate output will change to 0. So once again your AND gate output will remain 0 only. I am assuming that no propagation delay in NOT gate and AND gate. So output always at 0 option is correct. Now if you check with option B, your output Y is always at logic 1 is definitely incorrect, because output is always at logic 0 is correct. Now let us verify with option C. Option C tells us that we assume certain propagation delays. So with the propagation delay means, let us consider that it takes some 3 nanoseconds. Our NOT gate takes some 3 nanoseconds and our AND gate takes some 5 nanoseconds of delay. Now your output Y can have transient logic 1. That means normally it's supposed to be 0. Transient logic 0 means normally it's supposed to be 1. Then for a moment it changes to 0. Then once again it will come back to 1. Only when X changes from logic 1 to logic 0. So logic 1 initially at X at 1, then changes to 0 means this particular fluctuation must take place according to this statement. Now let us verify. I am assuming that X is initially at 1. So at this point we are applying 1. What may be the output of NOT gate at that instant? So it must be 0 at that time. Okay. Assume that it has taken place long before. So when it was 1, this must be 0. Applying this 1-0 combination, your output of AND gate is going to be 0. Now what we do? Changing the input from 1 to 0. So now when I change the input immediately into 0, your NOT gate will not change immediately, right? Even though it changes from 1 to 0, this change in 0 will not occur here only after 3 nanoseconds. Till that time what happens? Earlier, one input only makes the output to become 0. After 3 nanoseconds, what happens? It changes to 1. Because your input 1 changes to 0, your NOT gate output will not change to 1 instantaneously. After 3 nanoseconds only, it changes from 0 to 1. Now let us check the waveform. When it is 1-0 combination, your output was 0. Now, one of the inputs for the AND gate changed to 0, but NOT gate has not changed. It still remains 0 only. So your output is going to be 0 at this instance. After 3 nanoseconds, it changes to 1. The other input going on with 0 means this 0-1 combination also produces 0 output only. So it is always at 0, even though we introduce propagation delays. So there is no transient takes place at output node. So option C is incorrect. The final option we are going to verify is output is logic 1 for small time interval. Okay, that means transient 1 takes place when the input changes from 0 to 1. So let us consider that input is at 0 and instantaneously changes to 1. What happens to NOT gate? When it is 0, this must be 1. And the output, because one of the input is 0, your output is going to be 0 only. So for this combination 0, 1, output is 0. For a moment, it changes to 1. So from 0, it changes to 1. The change in 1 takes place immediately here, that reflected here. But here, this 1 changing the input 1 into, it has to change the output into 0, right? That takes place. The change in output of NOT gate to 0 will take place only after 3 nanoseconds, let us assume. And because of that, both the inputs are high for a momentary time. So your output for 1-1 combination goes 1. After 3 nanoseconds, because the NOT gate output changes to 0, once again it is coming back to 0. So for a moment, there is a logic 1 transient takes place according to option D. So option D is correct. Thank you.